To start with, what is Google Cloud Healthcare API? Basically, it's a fully managed cloud service, and we're targeting builders as opposed to buyers who want to create their own healthcare solutions. They can use our healthcare APIs to accelerate their solution development. It's the primary API surface for data ingestion of healthcare-specific data. So included in those APIs, we have, of course, the FHIR APIs. We also support HL7v2 messages, and we also have medical imaging DICOM APIs. And these are all somewhat similar in that they allow the storage and standardized HTTP APIs around that data. Of course, when we're storing healthcare data on the cloud, we're making sure to adhere to compliance with regulations. So we support HIPAA compliance and other big compliance regulations. And then we also integrate with the rest of Google Cloud. So for example, we have de-identification capabilities. So you can de-identify your FHIR data or your medical imaging data. We also integrate with other well-known Google Cloud applications, such as BigQuery, Vertex AI, which is our AI suite, Google Cloud PubSub, which is a event notification system, and Cloud Functions, which is a serverless way of executing code. And then another thing to note is we also support smart on FHIR application development. So this basically shows what I just said in a visual diagram. At the center of the diagram is where you can host and store your healthcare data, and we'll manage your data for you. So using the standard REST APIs, you can do create, get, list, delete, search, those standard APIs for your healthcare data. But we also support some other different ways of interacting with your data. You can also do bulk imports. So you can put in a large amount of FHIR data via a new line delimited JSON file and import those FHIR observations en masse. And you can also export them to Cloud Buckets or BigQuery. We also have de-identify, which I mentioned before. And we also have the event-driven notification. So you can trigger different workflows based on ingestion of a FHIR resource. And then these are our specific capabilities that I want to call out. So in terms of FHIR versions that we support 2, 3, and R4. And that you can configure that as you're creating a Google Cloud server. We also have import and export, which I mentioned before. And then the standard FHIR CRUD operations, create, read, update, patch, delete, etc. We also support conditional creates and updates and deletes. So if you do a search query based on a specific identifier, you can update that just using a search query. And then we also support a variety of FHIR operations. Of course, FHIR search, patient, everything, observation, last N, and bundle execution. We also have a feature in preview for translating between value sets. And then I mentioned notifications and de-identification. So that gives us a big picture of like the capabilities of our FHIR service. But I want to highlight 3 things in particular that have come to fruition in the past year. So the first one is FHIR profile validation. In our FHIR profile validation implementation, we support the posting of structured definition resources, and that allows you to validate the incoming resources based on that structured definition. You can also put those structured definitions with various implementation guides, so you can choose to implement all the standard implementation guides, as well as implement any custom structured definition resources you may want to implement. We have support for slicing, min-max, type, fixed, pattern, min, value, max value, and assorted, some of those other ones in the structured definition rules. You can also just run the validate operation to validate a single resource. if you don't want to post it to your FHIR server. And we'll go into a demo of this in a few minutes. The second feature I want to highlight is FHIR export to BigQuery. So we've had this for a long time, but we've made some improvements to this. We're following the FHIR standard SQL projection, but we've made a few improvements based on what customers have told us. So one thing to note is that contained resources are not supported in the FHIR to SQL projection, but we've made enhancements to allow that to be also projected into BigQuery tables. We've also made improvements to support repeated extensions. So for example, a common one is a patient has multiple races listed in their extensions, and we support repeated values for extensions. So this is a way you can run analytics on your FHIR data using standard SQL query, and we'll show this off in a demo as well. And the last part I want to highlight is our FHIR data exploration and search UI. So this is a web UI that allows you to explore your FHIR resources that you're storing with us. And it allows you to create custom search queries without having to know the specific details about how a FHIR search query is constructed. So in this GIF, which we'll show in the live demo, you can see there's some intuitive drop-down boxes where you can construct queries without having to know the exact way to specify it. And with that, I've been talking about these features. Let's actually see them. I'll pass it on to Dharmesh.
Thank you. And I think we have this documentation always up to date, so you can go and take a look at it. But what I'm going to cover today is 4 things. We will configure a FHIR server, and you can see how easy it is and how quickly you can configure a FHIR server. We will also import some test data, which is already preloaded into Google Cloud in storage buckets. And once those data is loaded, we can see how FHIR profile validation can be enabled on the FHIR data store. We'll also look at and explore the search capabilities supported out of the box on the FHIR UI, as well as the API capabilities. And we will finally look at how do you export the data from FHIR data store into BigQuery and run some SQL queries on top of the BigQuery. With that, quickly, let's configure the FHIR server. So I have it open here. If you go into the Google Cloud platform, this is called Google Cloud Console. In the left menu, you have healthcare as a managed service. You select that, and when you click browse, you can browse different types of data sets that you have already created. If you've not created anything, this list will be empty. With the click, and whatever I'm showing here through UI is all possible through RESTful APIs. So you can create a data set, you can create a data store, you can modify data set, data store using RESTful APIs. I'm going to create this new FHIR data store or data set, called FHIR DevDays. And this is, I'm creating into US Central 1. Now we support multiple regions here, as you can see. Plus we also support multi-region data sets. In that case, you can have, you can select something like US as your region, and then it will create the data across the US data centers. But for this demo, I will just create US Central 1. Now inside, think of data set as a container of different data stores. And as you must have seen in the diagram that Bob shared before, there are multiple types of data you can store within a data set. So once you go into the data set, if there are any data store already created, you can browse them here, or you can create new ones. And as I said, multiple types of data store you can create because Google Cloud Healthcare API supports FHIR, DICOM, HL7 v2, as a storage mechanism. Today we are going to look at the FHIR data store, but you can instantiate a different types of data stores as well. Now I'm going to create an R4 Firestore, and as I'm creating it, I'm also providing some information, some metadata information about the FHIR data store. So I'm creating a FHIR R4 compliant data store. I'm clicking this. Basically, this will allow you to update your or create your new resources using HTTP put when you use APIs to create the FHIR resources into your data store. Or you can use your post, which is required, but with the put, if you have an identifier, resource ID, that you want to select as you're creating a new resource into the data store, I think it is more handy to do put. So with put, it can create a resource. If the resource does not exist, it will update. If it exists, it will update it. If it does not exist, it will create it with the ID that you provide. The next capability you can turn on is streaming to BigQuery. So we saw that there is a way to export your data from FHIR data store, which is storing natively your data in JSON FHIR format. You can have a streaming connectivity just through configuration between FHIR data store and BigQuery. And what it does is every single mutation that happens on the FHIR data store is available in the BigQuery table as a raw. So you can have a transaction log of everything that happened on your FHIR data store in BigQuery so that you can do SQL analytics on top of it. I'm not going to do anything right now here. You can receive cloud PubSub notification. This is for building an event-based architecture. If you, let's say your applications wants to listen to the changes that are happening onto the Firestore, you can point it to a pre-created PubSub topic, which is equivalent to a Kafka in GCP. You can identify which PubSub topic you want the data store to publish events to, and then you'll have to write an event listener that would pick up and do whatever it needs to do as part of your application coding. We did that, and then you can annotate your data store for any use of machine learning or stuff like that, for labeling and all of that. Once you create it, it will create a new FHIR data store of type FHIR, which is R4 compatible in the data set that we created. Now, after you create this, let's import some data. So I already have some data created using FHIR's synthetic database patient generator, which I have it stored here in the ND-JSON form, and it's stored into Google Cloud bucket, which is an object storage mechanism in Google Cloud. They are stored in ND-JSON format. As you can see, all of this has been generated using Cynthia, the synthetic patient data generator. Let's look at one of this file. It looks like this. Basically, each line in this ND-JSON file is a FHIR resource in a JSON compliant format. So we will ingest data from these ND-JSON files, which are in this particular bucket. As part of the ingestion process, we'll select the location from where we want to ingest it, which is a cloud storage bucket. I'll select the test data, FHIR R4, and ND-JSON, and that's pretty much it. So when I select this bucket, all the ND-JSON files from that will be imported. There are different types of import mechanisms supported. So if you have data that are in bundle format, FHIR resource bundle format, you can have those. So each line in the ND-JSON is a FHIR bundle resource. Or you can have FHIR pretty resources, meaning all the FHIR resources are JSON, individual resources. Or you can have each line containing a FHIR resource in an ND-JSON, not a bundle resource, but a FHIR resource. Or you can have a resource itself. So we are going to just pick this one because that's our file format. And when we click import, it runs a long running transaction, which is long running, but it apparently finishes very fast. So this is right now running, but while it is loading, let me go back to what we did so far. We created a Firestore, We're importing some FHIR data, and soon we will be browsing once all the data is imported. Next, we will look at the FHIR profile validation. In the FHIR profile validation, we will have to do the same thing. If you look at the implementation guide is composed of different types of FHIR resources. Like implementation guide itself is a resource, structure definition, value sets, concept map, and code system, and so on. What we'll do is we'll import an entire implementation guide for US Core 4.1 profile, and then we will see how we can enable that. So this is running the import transaction. We can start another import transaction on the data store. To this time, we are importing a FHIR implementation guide. FHIR implementation guide, and I have a bunch of them downloaded here from hl7.org. I will take this, which is R4, and each one of these is a JSON file, and they are FHIR resources. So this time the import mechanism that I'm going to use is resource pretty, because each individual file is a JSON file. So that will start another long running transaction to start importing the IG resources, the implementation guide resources, into the Firestore, while we have already imported the data. So let's look at the data in the FHIR Viewer. So the Cloud Console also comes with Healthcare API, comes with a nice feature to browse the FHIR data that you've just imported. This is more for an operations use, not so much of a use for clinicians or end users, but for operations people, this becomes very handy sometime when you want to do some quick analysis on what is inside the store. So this is how once you load the FHIR Viewer or Firestore Explorer, you will have access to your data set and Firestore. And then as part of this, we ingested some data. So let's look at the patient that we looked at from the file. I think we had about 12 resources in this NDJSON file, which we just processed. I mistyped it, looks like. So all these 12 resources are also available. You can browse through this. You can go in here and you can look at this pretty hierarchical view, as well as you can look at the raw JSON. The other good thing about this UI is if you want to look at the relationship between some of these resources, and I'll come back to this viewer again when we will do the search part of it. Okay, I think I should have just okay, I think it's doing something. But so that's how I think we covered the first part, and we've already imported the implementation guide. Let's look at it, what we have implemented so far. Has the operation been successful or not? So I think the second import operation, the first one was successful, which imported a bunch of data from the NDJSON file. This is the second one, which imported the implementation guide resources. They both successfully completed. So now if I go back and look for condition resource, I have a bunch of condition resource and we can browse through the condition resource. But I think the beauty about this is you can see the references here and you can traverse through the references. So this condition is recorded for this particular patient. So now you can have a summary view of the patient, as well as you can have detailed view by clicking that particular patient. And you can also have an encounter reference, which is what the condition, when the condition was recorded. So that's it about the FHIR Viewer for now. So let's look at some of the implementation guide resources that we imported into the FHIR data store. Structure definition. Also, there is a nice little tool to look at what all implementation guides have been already implemented and are already imported into the data store. I will go through that. But these are all the structure definition resources that's been imported. Again, like the patient resource and condition resource, you can look through your structure definition resources and also traverse the links if there are any references through this user interface. Additionally, you can go into the details and it will show you which implementation guide has been imported or is available for you to enable. So this shows that we've just imported US Core 4.1 and all the resources needed to enable US Core 4.1 is available in the Firestore now. Just by having the resources into the implementation guide resources into the Firestore, it does not automatically enable it. You have to explicitly enable the guide, the implementation guide. And I'm going to show you that process of enabling an implementation guide using something through an API. So we have, if we look at the Firestore configuration right now, this is just a GET call on to the Healthcare FHIR API to get the configuration of the Firestore. So it just brought back this JSON, which is basically giving me information, metadata information about the Firestore. It is saying where the Firestore has been created, what is the name of the data set, what region it has been created, which is a fully qualified URI for that Firestore, as well as what other configuration has been enabled, like notification configuration. If you remember, we enabled PubSub notifications. That's what it is, what version of that Firestore is. But there is no validation configuration here turned on. So for you to make your Firestore validate resources against R4 or US Core, it is R4, but US Core, you have to make changes to the Firestore configuration. And for that, you can execute this patch call, which is basically patching the Firestore configuration on the Healthcare FHIR API. And you are adding a validation config here by saying, this is the implementation guide I want to enable. And this ID of this implementation guide needs to match to your implementation guide resource that you have imported in your FHIR Viewer. So we've imported only one implementation guide, which is US Core, and the ID for that is this. So we are through API now, we are enabling or we are adding that configuration. Something wrong. Yep, that's good. Yeah, but that's how you validate. I think in interest of time, I will move on. There's some typo in the ID of the implementation guide. So once you've enabled your IG, you can validate on insert by just doing a normal post like this, or you can just run when you try to insert using HTTP post. The validation routines will make sure that your resource is compliant to US Core R4, but there is a special operation called $validate, which can also let you, and I want to show you that $validate operation. Yeah, here. So this is basically where you run the dollar $validate in the URL, and this is compliant to the FHIR specification, where you can specify a FHIR profile against which you want to validate this particular insert of a patient resource from this particular file. That's how you can run the validation during insert. Moving on, let's explore some of the search capabilities through FHIR Viewer. And all this functionality that I'm demonstrating through UI is all possible through APIs, the RESTful APIs. So under the search, it gives you nice little utility to search based on, for example, look at this. Typically, when you do a search on an API, you would use the query parameters like this, right? Contains, exist, and so on. But here you don't need to do that. You can just say, I want to search for, through a query builder, you can say I want to search for a patient resource, and then you can continue, and then it basically progressively build the query that you want to, right? So for example, I want to search by a country code, and I put some value here. I can add conditions and so on. When I do, at the end of the day, it also gives me on the right side the query preview. So it's builds the query, and then you can continue, and then when you're done, it just shows here you have ability to even unlink it and edit it. And then when you run the search query, it will execute that and give you the results into the window. You can do all kind of things here. You can do include, reverse include, you can do reverse search, and all of that. That's supported in the FHIR specification. And then finally, what we'll look at is how do you bulk export data from FHIR data store into BigQuery so that it is available for SQL processing. Again, we go back to the console, we select the data store, and the action this time we will do is export. And in the export, like Bob said, we have two different destinations where you can export. You can export into Google Cloud Storage Bucket, which is a flat ND-JSON files it creates, or you can export it into BigQuery dataset as tables. In this case, we will export it to BigQuery, and we will browse through. This is so let me go to the BigQuery for a moment. So in BigQuery, you can create something called a data set, which is the holder of the tables. And then underneath that particular, you can create multiple tables. So in this case, all of these is exported data that I exported from a different Firestore. But I have this, actually, I don't have a data set. Let me create one data set quickly, a new one in BigQuery. Because you need you need a data set in order to export your data from FHIR data store to BigQuery data store. So now I have an empty data set here, and there is no table here inside this particular data set. What I'll do is I'll go back to my export configurations, and I will again BigQuery export. I'll select the FHIR DevDays, the one that I just created. And then I can select the recursive structure depth. This is when you have JSON is recursive. You can limit how much you want to export, up to what level, and you can go up to 5, and you export it. And then it will, because we selected delete existing, it can also append if you already have data in tables. You delete that and just export it. What it will do is it will start a long running transaction, another one for exporting the resources. While it is exporting, let's look at some of the data that we have already exported here. And as you can see, these are a bunch of one table per resource type. So we have patient, and this is the this is where you can preview, and it is available in an analytics-friendly, SQL-friendly tabular view. In addition to that, using BigQuery Query Builder, you can execute queries. I have some saved queries. We can pull them up and we can execute them. So this is one of the query that I am running on a projection from a data store to a BigQuery. It's a simple select on a patient table. When I run this, I can get the SQL. I have other queries like length of stay, which is a little bit more complicated than get patients and encounters by patient as an example, but you can run all kinds of queries here. So with that, I think I'll wrap it up. I hope I'm not over time. And if you have any questions, both Bob and I are available via email and also on Zulip. And these are some of the other sessions from Google throughout this conference. So please feel free to attend, and you will learn more about what else we are doing with Healthcare FHIR API and other associated technologies. Thank you. And we can take questions. We have 5 minutes, right? Yeah, we can take questions.
Oh, yep, there we go. Quick question, and I apologize if this was covered at the beginning. I missed the first couple minutes. I think I came in right at the tail end when you were talking about data ingestion, but I've heard more and more post-pandemic that it's becoming a lot more common for physicians to use Google Forms. So for instance, I know, at least in Canada, I've heard a lot of physicians are sending out Google Forms for things like intake forms. So it's got me thinking, is there currently, or are there any plans in the future to support funneling data from Google Forms into the cloud infrastructure so that it can be queried with FHIR, like, for instance, a series of questionnaires?
So if you enter information via Google Form, you would need to convert that into a JSON FHIR resource to be ingested. We don't have official support because, like, obviously with the Google Form, there's many different things you can set up. You can choose many different fields and things to enter, and somehow that has to be converted into a FHIR resource. In general, like, the challenge of turning stuff into FHIR resources is a common one. So we do definitely think about that a lot, about how we map data sources to FHIR, and Google Sheets or Google Forms would be just one example of that.
For sure. Cool, thanks. Awesome. Thank you.
Yeah, thank you guys for presentation. And the question, how can I load my custom implementation guide?
Sure. So Dharmesh showed a US core where he just downloaded the implementation guide and he uploaded those FHIR resources into our FHIR server. And then he ran a command to activate that implementation guide. If you have a custom one, then it would be the same thing, except you wouldn't download it. You would just create those FHIR resources yourself. So you could create those structured definition resources and then bundle them up together in an implementation guide resource, and then enable that resource if it's in your FHIR server.
Yeah, thank you. And will terminology work with it? I mean, all the value sets, if my implementation guide contains the value sets and some other stuff.
Yes, it will. So as part of the implementation guide, if you add your terminology resources like value set, concept map, and others, it will honor those.
Mm-hmm. So you have some built-in support for SNOMED, LOINC. So if I describe my value set as a queries, so it will be calculated automatically, yes?
That's correct. Yeah. I think it has nothing to do with enabling or importing the implementation guide resources into the FHIR data store, but it is more around code/select translation, and there's a $translate operation that is also supported on the Firestore. So you can do the $translate from SNOMED to other coding system.
Okay, thank you. So you have built-in terminology server, and you understand most of popular.
We don't have a built-in terminology server because some of these terminologies are licensed.
Yeah.
So we support, if you have your terminologies licensed, you can bring them in and load it, and those will be supported through the standard FHIR APIs.
And in which format I can load the terminology? Let's say CPT. I would like to load the CPT terminology into my FHIR server.
Then you'll have to bring it into the FHIR form and then load it into the FHIR form.
In FHIR form, you mean the coding system? So
that's correct.
this huge JSON file with millions of code. Okay, thank you.
Yeah, I had a similar question. Do you support terminology in BigQuery? So can I query on is a code in a value set?
You can run a SQL query on anything that you can export from FHIR data store into BigQuery as a table. So if you've exported a code system resource into BigQuery, you get a table and you can run a SQL query on that.
Okay, thanks.
Okay, his hand goes first and then I'll be back.
We saw at one part that you have the ability to identify data, right? So does this run a predetermined algorithms to de-identify the data, or do you plug in your algorithms? And if you export this data de-identified, are you able to correlate back to it once you import it?
So for DID, it's a mixture of rules-based and AI methods. What we'll do is scan the FHIR resource for any instance of PHI. And we have some custom profiles and some standard ones. One of the standard ones is taking out all the HIPAA 18 identifiers, such as names, MRNs, those kinds of things. But you can also specify specific info types that you're looking for. And what we do is scan everything. And if we see an instance of that, we'll take it out. And then I believe what you're mentioning, specific like rules-based ways, you can specify specific fields that you always want to redact. For example, patient.name or something. If you always want to redact that, you can do that. And then in terms of tracing it back to the original patient, we do offer crypto hashing as a method to transform PHI. So that would be a one-way deterministic map. So for example, if you had a patient with 10 different observation resources, you could de-identify all of those, and the patient ID or the name would be all crypto hashed into the exact same hash, so that you can identify that as belonging to all the same patient. If the actual text is in the FHIR resource, then we'll de-identify it as well. But if you're talking about like binary or hyperlinked data, then we wouldn't be able to de-identify that. But any text in the actual FHIR resource, we can scan it and look for PHI.
I just created a Firestore while you were talking. That you can use to store all the de-identified data. So now I have two different Firestore here in my Explorer. One is my base Firestore, sorry, wrong window. My base Firestore and my the Firestore to store the de-identified data. And then all I have to do is just go here and then just say de-identify. Now, this is where you identify where you want, what is your destination data set and destination store. And then you have option to append and then de-identify. This is the default configuration out of the box, but then you can change as per all the rules you can define, which is also another JSON where you can define redact or date shift or use one-way hash or even encryption keys if you want to reverse it.
If I export the data, the some vendor that we did some work on it, and I want to collaborate it back to the person data set that I have. Is there anything out of the box up there? Or what do we?
Reverse de-identification, we haven't done that. So if you have a de-identified data, out of the box, you will not be able to convert it back into its original form. But because some of this is one way, right? Like one-way hash, where you have encrypted the data, you have the keys so you can decrypt it. So that you can do, but it's not out of the box, right? It's not point and click.
Yeah, I'll say there have been some customers that have asked for the same thing, and what they've done is manually create a map from like the original resource ID to the de-identified version. So if you record the original resource ID and then you record the de-identified resource ID, then you can manually keep a log of which resource maps to which resource. So that's a little bit of a manual effort on your part, but certainly doable.
Oh, hey, thanks for the presentation. So you all mentioned the structure definition. Do you have any plans or do you currently support any like Firestore configuration or validation based on capability statements? And then I'm assuming that you're using the HL7 validator for the validate operation. Is that right?
I don't think we're using HL7 validator.
Okay, you like rolled your own?
This has been written
Okay, cool.
by Google, but your first question around, sorry, say that again.
Oh, yeah. So you mentioned the validation based on structure definitions, but do y'all have any plans or do you currently support like defining Firestore capabilities based on implementation guide's capability statement or validation based on a?
It's only based on structure definition as
Okay,
far as I
cool.
know. Bob, you know more?
Yeah, it's the whatever you put into the structure definitions.
Cool. Awesome.
All right, any last questions? All right, if not, thank you for your time.
Thank you.